Hello students, today I will discuss some problems related to acids and the bases, and that problems will be totally based on the IJSO level. Question number 1. Calculate the molarity of sodium hydroxide solution which was prepared by dissolving 10 grams of solute in water and was made to final volume of 200 ml. So while solving this problem, first of all we'll write what is given into the question. Given the weight of NaOH, or we can say the more appropriate term will be the mass of NaOH, which will be 10 grams, and the total volume of the solution is 200 ml. Now we have to calculate the molarity. We have to find the molarity of the solution. The molarity can be calculated by using the formula molarity, which is denoted by capital M, is equal to number of moles of solute which is to be dissolved in a volume of solution, and that volume has to be specified in liters. But in a question, the weight of NaOH is given, as we know that number of moles of any substance is equal to its weight divided by its atomic mass in case of atom, but in case of molecule it is equal to the molecular mass, and in case of formula it is equal to the formula mass. So number of moles of solute is equal to weight of NaOH, which is equal to 10 grams, by its molecular mass, which is equal to the 40 grams. This will be the number of the moles of NaOH multiplied by volume of a solution in liters. Now here the volume is given in ml. We'll convert it into the liters by dividing it by 1000. So it will come out to be 10 into 1000 by 40 into 200. So the molarity comes out to be 5 by 4, and it is equal to 1.25 molar. Now we'll see the second question. Second question is 2.5 gram of solid organic acid with molar mass of 126 was dissolved in distilled water and was made up to 250 ml in a volumetric flask. 25 ml of solution required, 39.7 ml of 0.1 molar. Find the basicity of acid. What will be the solution of this question? Firstly, we will calculate the number of moles of the organic acids in 250 ml of the water. Now, number of moles of organic acid will be equal to its weight divided by molecular weight. So it comes out to be 2.5 divided by 126, which is equal to 0.0198 moles. Now these moles are present in 250 ml water. As in a question, it is given that 25 ml of a solution requires 39.7 ml of 0.1 molar NaOH. So, we'll calculate the number of the moles of the acid in 25 ml of the water, as 250 ml of an acid contains 0.0198 moles, whereas 25 ml of water contains X moles of organic acid. So, number of moles of the organic acid will come out to be a X equal to 25 multiplied by 0.0198 divided by 250, which comes out to be a 0.00198 moles. Now, number of moles of NaOH is equal to molarity multiplied by the volume of solution in liters, as 25 ml of the organic acid solution requires 0.1 molar NaOH in 39.7 ml solution. So, moles of NaOH will find out to be a 0.1 multiplied by 39.7, which is equal to 0.00397 moles. So here, now to calculate, what we have to find is the basicity of an acid. Here the basicity of an acid will be found with respect to the base, which is NaOH. So to find the basicity of an acid, what we'll do is we'll just compare the moles of the NaOH with the moles of an acid. So number of moles of NaOH by number of moles of acid, and we'll just put the value of the number of the moles of NaOH and then the number of the moles of acid, which is 0.00198, and it will be approximately equal to 2. So the basicity of an acid will be 2. Now next question, what is the pH of the following solution? We have to calculate the pH of 0.01 molar HCl. Now, as we know that while calculating the pH, we have to focus on the H+ ion concentration. As we know that when we are dissolving the HCl into water, it gives H+ ion plus Cl negative ion. So here, from 1 mole of HCl, 1 mole of H+ ion is obtained. So the concentration of the HCl will be equal to the concentration of the H+ ion. So the concentration of the H+ ion will be equivalent to the concentration of the HCl, which is equal to 0.01, and we can also write minus log 10 raised to power minus 2, which will be equivalent to minus 2 log 10, and it comes out to be 2 because log m raised to power n is equal to n log m, and here n is 2 and m is 10, but the value of log 10 is 1, so pH comes out to be 2. What is the second one? We have to calculate the pH of 45 ml of 0.01 molar HCl and 45 ml of 0.01 molar NaOH. As we know that NaOH and HCl, NaOH is a strong base and HCl is a strong acid. Salt formed by it will be a neutral salt, because salt formed by the strong acid plus strong base will be always neutral in nature, will always be neutral in nature. So NaOH when combines with HCl, it gives what? NaCl plus water, and in the above mentioned data, the number of the gram equivalents of the HCl is equal to the number of the gram equivalents of the NaOH. So pH found to be a neutral. So solution is neutral and pH will found to be a C1 is 45 ml of 0.01 molar HCl and 55 ml of 0.01 molar NaOH. Again, it's the case of the strong base plus a strong acid, but here the concentration of both the acid and the base is found to be different. Now we'll see the another method how to solve this question. We'll find the number of the milli equivalents of both the NaOH and the HCl. And what formula we are using for the acid-base mixture is number of milli equivalents of the one whose concentration is more minus the number of the milli equivalents of the one whose concentration is less, that is N1V1 minus N2V2 is equal to N3V3. In the above data, the number of the milli equivalents of the base is found to be more, so we'll consider N1V1 as base and N2V2 as acid. So what we'll do is we'll consider the normality of NaOH, as the normality and the molarity of NaOH will be equal, because here the number of the replaceable OH minus ion is 1, and in case of HCl the number of the replaceable H plus ion is 1, so their normality and molarity will be equal. Now what we'll do is the normality of NaOH is 0.01, its volume is 55 minus N2, that means that of acid, that is HCl. Its normality is 0.01 and its volume is 45. We'll calculate the normality or the concentration of the resulting solution, and the volume of the resulting solution will be V1 plus V2. So here it comes out to be 0.55 minus 0.45 equal to normality of the resulting solution multiplied by 100. So the value of the N3 comes out to be 0.1 divided by 100, which is equal to 10 raised to power minus 3. Now the resulting solution will be basic in nature, as the concentration of NaOH is more than the concentration of the acid. So it will be the concentration of the OH minus ion, because the base contains the OH minus ion, so the concentration of the OH minus ion will be 10 raised to power minus 3. Now by using formula, POH is equal to minus log of OH minus ion concentration, So it will be minus log 10 raised to power minus 3, which comes out to be again 3 by using the formula log m raised to power n, which is equal to n log m, because the value of log 10 is 1. Now again pH plus pOH is equal to 14. So if we know the value of pOH, then we can easily calculate the value of pH. Here pH is equal to 14 minus pOH, which will come out to be a 14 minus 3, that is 11. As it is more than 7, so we'll recheck whether the nature of our solution is true or not. As we have find the nature of our solution is basic, so we can clarify it by calculating the value of pH, which comes out to be 11.